Hi friends, in this video we are going to configure constraint-based RSVP LSPs in OSP in Nokia routers, or you can say SROS. And topology which I am using is a simple topology which I am using in my all videos: R1, R2, R3, R4, and OSPF is running in area 0, and LDP is enabled on all the interfaces on these all four routers. So today uh, we'll see how RSVP based LSP will be configured. So to simplify the things, what I have done, I have write down the tasks which we are going to perform in this complete video step by step so that you can easily understand. So first step was to configure a LSP named R to R2-1 from router 1 to router 2 using a fully loose path. Okay, so let's start. So let's start. This is my R1. This is my R2. I am able to ping system IP of R2. Sorry. Okay, it's pingable. So to configure a LSP, first we need to call the interface in MPLS. Okay. So configure router MPLS interface to R2, shut back interface to R3. I am also adding because later I need it. Okay, info. Look, no shut MPLS services, no shut. Now what we need to do is we need to create a loose path, right? That is what we need to configure, fully loose path. So now configure MPLS is already there, path, and loose LWSE. I am giving the path name. Okay, no shut. Okay, so exit loose is just a name of the path. You can give anything, right? So info, again we can see we have configured a path with the name of loose. Okay, now what we need to do is we need to configure the LSP, right? LSP, what our name is 2R2-1. Okay, and after that you need to give the two. कहाँ से we need to up to 10.10.2 CSPF, no shutdown, info. LSP is created, but we have not given the path in LSP. Okay, so primary, sorry, primary path होगा loose exit down. So next, what I need to do is configure router RSVP, no shutdown, and one more thing I need to enable for traffic engineering is configure router OSPF traffic engineering, that I need to enable admin save this configure, and my LSP, that is configure show router MPLS LSP, that is down. We'll see later why it was down. Let configure the next task. Configure LSP named to R1 from router 2 with the fully same thing we need to configure on router 2 configure. So what we need to do is configure router MPLS interface to R1 R4 also I am taking. No shut. Back interface to R. Interface to R4 I'm also taking. Okay. Okay, and back. Sorry, caps lock is on back. Path loose. Sorry, path loose. No shut. Back. No shut. Info. So this thing we have configured. Now we need to configure the configure our MPLS LSP to LSP to R1-1. Okay, to 10.10.10.1. Right, primary path, primary, sorry, loose, back, info, no shut, back info. Okay, and next thing what we need to do is configure router RSVP. So once you add the interface in MPLS, right, it will automatically show the same interface in RSVP in Nokia. Okay, so you just need to shut down. Okay, so back configure our OSPF traffic engineering knob. We need to enable configure router OSPF TI traffic engineering. Okay, exit all admin say show router MPLS LSP. Okay, it is up. So just like drag it down a little bit. It's up, admin up, and operational up. Now check here also on router 1. Still down. What is happening? Here it is up. So here LSP is up and R1 also LSP is up. So let's move to task 3. What I need to do is so configure LSP R2 to R2 on router 1 to router 2. Use the T metric to make the LSP follow the path R1, R3, R4, R2. So what path I need to follow is R1, R3, R4, R2. So let's do it. Come on R1. Okay. So first I need to do enable and MPLS on interfaces on R3 and R4. That's what happening. Okay, configure router MPLS info interface to R1. No shut back interface to R2. Sorry, R4. No shut back. No shut. Let's start again. So info back exit configure router RSVP info. Okay, so no shut exit and OSPF on router 4 is here, admin configure router OSPF traffic engineering back and look, cannot create RSVP without creating a MPLS. So first I need to create a MPLS. Configure router MPLS interface to R2 no shut back interface to R3, sorry, no shut back info no shut, okay, and back exit all configure router RSVP. Now I can do right info no shutdown. Okay, so now we need to configure LS. So in third step, we need to configure LSP named to R2 to R2 from router R1 to router R2. Use a TE metric to make this LSP follow the path R1, R2, R3, R4. So we have one way to follow R1, R2, R3. We can create a strict route, right? But it is not asking to create a strict route. They want us, the task want us to use a T matrix and make sure that this will show you choose the path R1, R2, R3, R1, R3, R4, R2. Okay, so let's do it on R1 and create a LSP. Okay, and we have already enabled the MPLS interface on R1 and R3 and R4. Okay, so R4 I think we have not unshut. Configure router MPLS configure router MPLS info. Okay, it's unshut. Okay, on R1 let's configure. First we configure router MPLS interface to R2. First we configure TE metric. We'll configure 8000. Okay. Configure router MPLS LSP to R2-2. Okay. 210.10.10.2. So 10.10.2 and of that CSPF use TE metric so that it can use the TE metric to identify the path, right? And primary, I'm still using loose path. Okay, and no shut back and no shut back info. So this is my path. Okay, so exit. show router MPLS LSP to so if we check the MPLS LSP, show MPLS LSP, show router MPLS LSP, both are up. And if we check show router MPLS LSP path detail, so now check the path of this LSP. Sorry, we have given a correct name or not? LSP R2 R2 2 hyphen 2 path. Okay, so it's taking 3 and then 4 to reach 2, right? It's taking 3 and 4 to reach 2. Also, we can check it like this: O and O A M O A M L S P trace to R2 hyphen 2. So go to 3 to reach 2, 3 4 2. So in this way we can check the LSP trace in Nokia. Okay, which path it's taking. Admin safe. So let's see what is the next task. Next task is configure LSC named R1 hyphen 2 from router 2. Use the hop limit to make the LSP flow a direct path from router 2 to router 1. Okay, so okay, so let's configure it on R2. Configure router MPLS, and what is the LSP name we need to give? R1 hyphen R2. Okay, configure router MPLS LSP to R1 hyphen 2. Okay, to 10.10.10.1 CSPF, and we need to define the hop limit to. Okay, primary loose back, no shutdown, exit all info, right? So check show router MPLS LSP. Okay, now both LSP are up. So my both LSP is up. If I check the path of this LSP, show router MPLS LSP, right? Path detail. It will taking a 2 hops, right? 1 to 2 directly hops. But if you check this also taking the same. So how we can differentiate between two LSP? It's working fine or not? So what I will do, configure router interface to R1. Okay, shut down. Now I have shut down this link. Show router MPLS LSP. So look, Now my R1 is came up, okay, but R2 is not because I have a hop limit in this LSP, right? For only two. And how this was came up? It will taking longer path now. To show router MPLS LSP to R1-1 path details. Look, now it's taking a longer path. Why is that LSP is not taking a longer path? Because it is having the hop limit 2. If I do configure router MPLS LSP to R1 hyphen 1 2, okay, 4, no hop limit. So router MPLS LSP, it's now up, but if I do hop limit 2, then it goes down in some time. It will take some time go down. uh, so we will do shutdown. No shutdown. Look, why it takes so much time? Because MPL is having the refresher timer, right? After that, LSP state will change, not immediately. So that is the hop limit we can define in LSP. Okay. So let configure router interface to R1. No shit. Exit show router MP MPLSLS. So next task is to configure LSP on R1. View R1, give name to R2 R3 on router R1 and use administrative group to make the LSP follow R1 R2 R1 R3 R4 R2. Here we have used a TE metric, right? And now we need to use an administrative group. So how we can achieve this? Go on R1, create one admin group, configure router if attribute admin group red value 1, okay, exit. Now configure router MPLS LSP to R2-3, right? Or first configure interface to R2 admin group. We have called this interface in admin group red, which we have configured. Okay, now configure LSP to R2-3 to 10.10.10.2. Okay, CSPF, and we'll do exclude red. Okay, so what we have given is in this LSP exclude the admin group red. So whatever interface is in admin group red, this LSP will exclude that interface, will not use that interface. So now primary lose, no shutdown, back, no shutdown, exit. Okay, info. Now check what is the LSP configuration. Is LSP configuration is 2 CSPF, exclude red, primary lose, exit, no shutdown. And this command also we need to give, it's already there, but we need to give admin group FRR. Okay, so now show router MPLS LSP. So LSP is up, so MPLS LSP, check which path it's taking, shortest or longest path detail. So now it's taking a long path, it's not going directly to the 2 because we have exclude red, admin group red. Okay, that is why it's taking red. So if it in same LSP, we will give this. Okay, info. If we remove no exclude red, so now check what path it is taking. It will take some time. Now it's taking the short path, right? If we do exclude red, it will take longer path. So that is all for this task. We'll do admin ready save. Okay, so let's move on to the next task. Now last task is for to configure LSP to R1 to R3 on router 2 to router 1, but this time we need to follow the strict part to make this LSP follow R2 R4 R3. So which one is R2 R4 R3? So we want from R2 to R1, this will follow the path, this longer path strictly. So we need to make a strict path here. So go on R2, first we'll do admin save configure router MPLS. Okay, and now we need to create a path. First p path to R1 hyphen strict path. This is a path name, you can give anything. Okay, so we need to restrict the path. So first hop should be 10 hop 10 dot 10 dot 10 dot 4. We need to strict it. Next hop is 10 dot 10 dot 10 dot 3 strict. Last hop is 10 dot 10 dot 10 dot 1 strict. Okay, now no shut exit. Now we need to create a LSP configure router MPLS LSP to R1 hyphen 3. Okay, to 10 dot 10 dot 10 dot 1 primary path होगा मेरा to strict no shut back no shut back info. Okay, show router MPLS LSP. Now LSP is up. MPLS LSP, let's check the path, which path it is taking. Is taking the correct path or not, which we have defined. Yes, it's taking a correct path. Another way which I told you to check the path, OAM MP LSP trace. You can check which path it's taking. Similarly, you can ping this also. LSP. So the last task is to verify that all the operational LSPs are operational. That is this thing we have already done step by step, and each and every step we have checked the LSP. So that is all for this video. Will Thank you for watching this video, and please subscribe and like my video and subscribe my channel if you want me to keep doing these useful videos, and if you think it is good and helpful, please subscribe and share my videos. Thank you.